So today we are going to be looking at what are called special right triangles. And the first special right triangle that we're going to talk about for today's lesson is the 45-45-90 triangle. So for the essential question, I want you to answer, how do you find the missing side lengths of a 45-45-90 triangle? So before we get to the specific way that we're going to look at the 45-45-90 triangles, I want to look at these just as right triangles. So we learned in our previous lesson that you can use the Pythagorean theorem to find the missing side of a right triangle. So if we were to apply the Pythagorean theorem to these three triangles, I want to see what we would get when we solve. So for this one here, remember C is the hypotenuse, which is always opposite the right angle. And the legs don't matter if you plug them in for A or B. So we're going to have 3 squared plus x squared is equal to 3 radical 2 squared. So 3 squared gives us 9. X squared remains x squared. And here we're going to multiply 3 rad 2 times 3 rad 2. 3 times 3 gives us 9. The square root of 2 times the square root of 2 is just 2. And that's going to give us 18. So to solve for x, we subtract 9 on both sides. We get x squared is equal to 9. We can square root both sides. Remember, when you square a square root, they undo each other, leaving us with just the radicand. So x is equal to the square root of 9, which is 3. So for this leg here, we get 3 as our answer. For this triangle here, same thing. This is our hypotenuse, so that'll be C. A and B are both 5. 5 squared plus 5 squared is equal to x squared. 5 squared is 25, plus 5 squared, which is 25, equals x squared. 25 plus 25 gives us 50. We can square root both sides. The square and square root undo each other, leaving us with x, and we can cake the square root of 50. That's 2 and 25, 5 and 5, and 5 and 1. That's going to give us 5 radical 2 as our value of x. And then here for our last triangle, again, the hypotenuse must be C. A and B are both x. So this is going to be x squared plus x squared is equal to 9 radical 2 squared. X squared plus x squared gives us 2x squared. 9 radical 2 times 9 radical 2 is going to be 81 times 2, which gives us 162. We then divide both sides by 2, giving us x squared is equal to 81. Square root both sides, and we get x is equal to the square root of 81, which is 9. So here we have found that x equals 9, so both x's will equal 9 because they're the same length. So what I'm going to do now is I'm going to erase all of this so we can kind of look at it with just the side lengths. So I want you to look at these and I want you to try to recognize the relationship between the legs of the triangle and the hypotenuse of the triangle for each of these scenarios. So notice that our legs are always the same measure. And this is what's called an isosceles triangle. If this is 45 and this is 90, the third angle must be 45 degrees to add up to 180, like we talked about with the triangle angle sum theorem. And an isosceles triangle will always have two congruent legs, and two congruent angles. Now, this doesn't have to be specifically a 45, 45, 90 triangle. An isosceles triangle can have any angle measures as long as two of those angle measures are the same, and the sides opposite those angles will also be the same. So again, the 45, 45, 90 triangle is one of our special right triangles. So what I want you to see is that anytime you have a 45, 45, 90 triangle, the relationship between the legs and the hypotenuse is that we're just going to multiply the leg by the square root of 2 to give us the measure of the hypotenuse. So here our leg is 3, we multiply that by the square root of 2, and we get 3 radical 2 for the hypotenuse. Here the leg is 5, we multiply the leg by the square root of 2, and that gives us a hypotenuse of 5 radical 2. And lastly, a leg here of 9, we multiply by radical 2, and that gives us a hypotenuse of 9 radical 2. So if we had leg measures of 1 and 1, what do you think the hypotenuse of this triangle would be? It would be 1 radical 2 or just radical 2. And this is what we refer to as the parent triangle for the special right triangle 45, 45, 90 degrees. So all of the questions that we're going to see, all of the problems that we're going to see today with our 45, 45, 90 triangles are going to refer back to this parent triangle here. We're going to add that into our vocab on the next slide. So our first vocabulary term is isosceles triangle. I just talked about that on the previous slide. An isosceles triangle is a triangle with two congruent sides and two congruent angles. Then we have our parent triangle, which we also spoke about on the previous slide. So let's go ahead and include that here. So again, with all 45, 45, 90 triangles, we have a leg here, and the hypotenuse is always across from the right angle. The leg measures are both 1. Our hypotenuse will measure the square root of 2. So what we're going to do is we're going to use these values to help us set up proportions for finding sides of a 45, 45, 90 triangle. Keep in mind that all isosceles right triangles are similar, which means that all sides are proportional to the parent triangle. So going back to finding missing sides like we did in the 7-2 lesson, we will use proportions to help us find those missing sides. So for GP number 1, we have here a 45, 45, 90 triangle. And the first thing that we're going to do to solve these, to solve for the missing sides of a 45, 45, 90 triangle is to set up a chart. So based on what we saw with the Explorer and the vocab, we have 2 legs and the hypotenuse of the 45, 45, 90 triangle. And so we will write the measures of the new triangle first, and we will put that over the measures of the parent triangle. So we know for this triangle here, remember the hypotenuse is always opposite the right angle. Therefore, y is the hypotenuse of the new triangle, making the legs of this triangle 9 and x. From the parent triangle, the legs are always 1, 1, and the hypotenuse is always the square root of 2. So what we're able to do here is to create ratios that are going to be equal to each other because all 45, 45, 90 triangles are proportional. So what you always want to take from this chart is the ratio that gives you both measures. So notice that here we have a variable and here we have a variable. So we want to begin by using this ratio here to help us find the missing sides. So we have 9 over 1, And we can set that equal to either of the other two ratios to begin with. It doesn't matter which one you begin with. So we'll go ahead and set that equal to x over 1. Now, whenever you have a number over 1, we know that 9 over 1 equals 9. We know that x divided by 1 equals x. And so we get a measure of x equals 9. Now here, it's also possible for you to cross multiply. If you were to cross multiply here, you would get 1 times x, which equals x, is equal to 9 times 1, which equals 9. So either way you see it, you're going to get the same and correct answer. Then for our hypotenuse, we're going to use the same ratio we were given, 9 over 1, and we're going to set that equal to y divided by the square root of 2. Here we will go ahead and cross multiply. 1 times y gives us y, and 9 times the square root of 2 is equal to 9 times the square root of 2. Nothing here needs to be simplified or rationalized, therefore this is our value of the hypotenuse. So now I want you to pause and I want you to go ahead and give this one a try on your own and then come back to me and I will walk through it and we will see how you did. So remember, the first thing that you need to do is to set up a chart. So we have the legs and hypotenuse. We will put the new triangle on top and the parent triangle on the bottom. So our new triangle, hypotenuse is x. The legs are 22 and y. The parent triangle is always 1 and 1 for the legs and a hypotenuse of the square root of 2. We will always begin with the ratio we're given, the one that does not contain variables, so that's going to be 22 over 1. Set that equal to y over 1. Those ones will divide out, and we will get y is equal to 22. For the hypotenuse, we use the same ratio. We cross multiply. X times 1 is x, and 22 times rad 2 is 22 rad 2. So for this triangle here, we are now given the hypotenuse and we're in search of the legs. We're going to solve this the same way, though, that we did with part A. So first thing we do is set up our chart. We have leg, hypotenuse. For the new triangle that we have here, our legs are x and y, and our hypotenuse is 34. For our parent triangle, our legs are 1 and 1, and our hypotenuse is the square root of 2. So we have our ratios, which we can use to set up our proportions. The ratio we have both values of is here, 34 divided by the square root of 2 is equal to x divided by 1. Well, now here we have the variable that's just being divided by 1, which we know is going to equal x, so we can just cross off that 1, and we have x is equal to 34 divided by the square root of 2. So we've already isolated the x. However, we have to make sure that our answers are always rationalized. Remember, we can't leave that radical in the denominator, so we must multiply by the square root of 2 divided by the square root of 2. That's going to give us 34 radical 2 divided by 2. We will then simplify both outside numbers, leaving us with 17 radical 2. Now for our y value, we know that the legs are always going to have the same measure. So we're going to get 17 radical 2. So when you see that we have a 45, 45, 90 triangle, remember it is an isosceles triangle, which means the sides opposite the congruent angles are going to have the same measure. So go ahead and pause the video and try this one, and then come back to me and see how you did. So again, we start by setting up our chart. We have x, y, and 10 radical 3. For the parent triangle, 1, 1, and the square root of 2. Start with the ratio we have both values for. 10 radical 3 divided by radical 2 is equal to x divided by 1. X divided by 1 is going to equal x, and our variable is isolated. However, we must also rationalize. See how you did with the rules of radicals here. Remember, we can only multiply inside numbers with other inside numbers. So the numerator will be 10 radical 6, and in the denominator, the square root of 2 times the square root of 2 is 2. We then simplify, leaving us with 5 radical 6. So x is equal to 5 radical 6. Again, the legs are always going to have the same measure. So y will also be 5 radical 6. Now notice that this measure was not given. However, because this angle is 45 and this angle is 90, the third angle must be 45 degrees. So even if we're not given all three angles, we know that the triangle angle sum theorem tells us that it has to add up to 180. Therefore, this will always be a 45, 45, 90 triangle. And that is the first of our 2 special right triangles. Don't forget to do your essential question.